In this video, I'm going to provide you with 3 different proofs for the Pythagorean theorem. Your goal is to pick the proof that would make the most sense to a young child and why you think that. First, we can only use the Pythagorean theorem with right triangles. So by doing this, we created a series of right triangles within the square. The second, by having a square, we make sure that we have a right triangle with congruent leg lengths. And so I'm going to fill in the triangle in the middle, right here. It has a right angle. Here's its hypotenuse would be right here, but its congruent legs are here and here. Now, if we look at the square coming off of this and the square coming off of this and the square coming off of the hypotenuse, each leg has 4 of the triangles within it. Oops. Now, if we look at the hypotenuse, which is this one right here, we have 1, 2, 3, 4. Hold on. I forgot to add in a diagonal line. There we go. 5, 6, 7, 8. Okay. There's 8 total triangles here. So the little square with 4 plus the other little square with 4 is equal to our bigger one with 8. In this one, we're going to look at a right triangle with the following leg lengths: 3 and 4. And so off on the side, we are just going to sketch in a box that is 3 by 3, and we want to add it to another box that is 4 by 4. We're going to start with our 4 by 4 grid, and then we are going to add on 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. And what we see is that this side is 5, and this side is also 5. Since we have a perfect square and each is 5 by 5, that means our hypotenuse here is equal to 5. Or another way to think of this is that 3 squared, because this is 3 by 3, plus 4 squared, because it's 4 by 4, is equal to 5 squared. And so for proof 3, we're going to look at a right triangle with a length of 5 and a length of 12. What we're going to do is break this first square into a side length of 5 and 12, 5 and 12, and cut it right there. What we see is that this little square here is 5 squared, and this big one over here is 12 squared. And remember, this triangle over here is formed when we have a length of 5 and a length of 12. So that's going to be this diagonal. And we have 5 and 12 here. So this diagonal here would also be our hypotenuse. You're probably wondering why I'm showing this, because right now this doesn't mean anything. We can't really see that h squared is equal to these put together. But what if I change the order and I alternate my sides between 5 and 12? Then this is 5 and 12, 5 and 12, 5 and 12. Remember, 5 to 12 gives me my hypotenuse. So 5 to 12 gives me my hypotenuse. So each of these triangles that I'm making here has this length, even though this isn't a great sketch, of h. So this first one, 5 squared plus 12 squared, is going to be equal to our hypotenuse squared.